So, now we are going to start our second lecture on friction tribology. So, in this particular chapter we will deal with the different types of frictions, what type of frictions we are getting from different bodies and what is the basic principles about those frictions. So, in first case or maybe the first slide we can see that there is some examples which some cases the friction is helping to us, some cases it also creates certain kind of problems to us also. So, from the left hand side figure you can understand if there will not be any frictions in between our body and the water we can't swim. Not only that, there is another examples that if there is no frictions in between your matchsticks and the matchbox, so it will not ignite. And not only that, in the winter also if we rub our hands and there will not be any frictions in between that, we will not get any temperature to our body. But simultaneously from the right hand side figure also you can understand that due to the frictions our shoe soles is continuously rubbing onto the road, due to that the friction is taking place and our shoe gets wear. Also in the engine parts where we are using certain kind of belts or maybe any kind of gear or pinion where there is a direct contact in between them, it creates certain kind of frictions. So, friction is having some merits as well as some demerits too. So, various attempts have been made to reduce it by lubricating surface with oil or greases and changing design so that sliding can be reduced. So, from these particular aspects we can understand that there are several applications, several types of remedies what we can adopt to reduce the friction. So, now in the next slide we will start that what is frictions and how it is creating some problem to us. So, friction is not itself a fundamental force, but it arises from interatomic and intermolecular resistance force between the two contacting surface. So, suppose as an example, if I am having these erasers, if I can rub it onto this board and there will of course a contacting area in between these two. So, due to that rubbing is taking place, but automatically there will be a friction in between these two also. So, from this particular figure we can understand that if a body is moving into a particular directions, the friction force will be generated into the opposite directions to the motions. Not only that, sometimes when the space shuttles or maybe aeroplanes or maybe helicopters, when it is going to the high altitude, so what is happening when it is going, its outer surface is getting rubbed with the tiny nanoparticles or maybe dust particles which is present into the atmosphere. So, friction is taking place into that point of view also. That means friction creates barrier in movement of aeroplanes as the particles in air resist the motion. So, what are the main causes that which can creates the frictions? So, first is called the microscopic forces of mechanical adhesions, electrostatic van der Waals forces, metallic bonds, and second one is called the microscopic forces of mechanical abrasions like elastic and plastic deformations. So, when a body is in moving in a particular directions, the friction force is acting in the opposite directions to its motions. That means friction force strength also depends on type of surface, as rough surface offer more frictions than the smooth surface. That means that if we are having two bodies and they are touching each other, so there is a contact points in between these two surfaces, and if the contact points will be more, so that means the frictional force will be more. If the contact points will be less or maybe the touching surface area of two particular point will be less, so automatically the friction force will go down. In the next slide we will simply discuss about what is frictions. So, frictions is nothing directly dealing with the normal load applying to that particular body which is known as N and the force generated opposite to the motions. So, suppose we are having two bodies and they are interacting each other, then the normal load will acting in this particular point and then this body is trying to go like this. So, if the motion of the body will be in these directions, its frictional force will act into these directions. What is the relations in between that? F is equal to mu into n, where mu is nothing but it is called the coefficient of frictions. So, from this particular figure you can understand that there are two bodies having two different surface structures. In that particular point, some points of that two bodies is touching together, some point is not touching. So, here the mu is directly depend upon the touching area of these two meeting points. So, mu is a nonlinear function of normal load. As normal load increases, coefficient of friction will automatically decreases and contact area increases, which cause the easier sliding. That means the surface area of these two contacting material will be increased. So, automatically it will create more sliding than the previous one. Now, there is having some materials which can give you different coefficient of frictions. So, from a standard literature review, we have found that aluminum is having 1.5, copper 1.5, gold is having 2.5, iron is 1.2 and platinum is 3. So, there are each and every material is having certain coefficient of friction value. Depending upon that, we can calculate that if we make any product, whether it is some nano size product or maybe macro size product, and if it can be used in our day to day life, then how much resistance it can get from the environment itself. In the next slide we can see that there are several types of frictions. So, from the last slide we can conclude that friction is generates only in between the two meeting parts, whether they can in the stationary motions or maybe they can into the movable motions. So, if the two bodies is in the stationary, they are not into moving, that friction is known as the static frictions. So, in the static frictions means, suppose I am keeping a book onto a table. So, there is no motions in between these two, but still they will generate certain kind of frictions, which is known as the static frictions. So, that means there is no relative motions in between these two surface. In that particular case, the relation will be the normal relations what we have explained earlier, that is F equal to mu into n. And not only that, here only mu will be known as mu s, which is known as the coefficient of friction in static. Next, the second one is called the kinetic frictions. From the name itself you can understand that kinetic frictions deals with that where the two bodies into the moving conditions. So, in that particular case, from this figure you can understand that children are sitting on a ice skating devices or maybe that ice skating playstations which is rubbing onto the ice itself. So, here the motion is into one direction and the frictional force is acting into the opposite directions. In this particular case, the relation will be F is equal to mu k into n, where mu k is known as the coefficient of friction for kinetic motions. Third one is called the rolling frictions. In our day to day life, every day when we are coming to office, when we are going to school, we are availing the bus, car, everything. So, when the car or bus or any kind of automobiles thinks it is rolling onto the road, so it's through its tire it is generating certain kind of frictions in between the tire and the road surface. That friction is known as the rolling frictions, when the force which slows down the motions of the rolling object. And last one is nothing but the fluid frictions. So, fluid frictions means it is the frictions which deals with the motions of a particular fluid into some medium. So, it is the friction between layers of viscous fluid that move relative to each other. Suppose a ship is going through the water, or maybe in our body when the blood is going through the vessel, it is creating certain kind of frictions in between that. So, due to that fluid, whatever the friction it is generating, it is known as the fluid friction. Then first we are having a simple example by which we can describe about the static frictions and kinetic frictions of a particular body. So, suppose I am having a body resting on a surface and it is having some mass. The mass is nothing but the mg. So, I am denoting that mass into mg over there. So, when in the first case, when I am talking about that there is no friction means that body is not moving, it is into the static portions, right. So, in that particular case what is happening, So, if it is into the static motions, so if it can go in this side, so automatically the frictional force will act into the opposite side, but in this particular case the body is not moving at all. So, if the body is not moving at all, its sigma Fy, so frictional force will be totally 0 over there, because it is into the static conditions, and also due to its mass, the mass will act into these directions, which it is relating with the theta angle. So, automatically it will give you mg cos theta, right, and your mg sin theta will be acting towards its x axis. Now, when we are dealing these particular equations from this particular figure, we can understand that just simply to normalize this force, that mg cos theta is acting onto the surface of that particular area, then here your n will be mg cos theta, which is acting towards its y directions. And next, as its function is totally 0, so only this mg sin theta will act to its x axis, which is nothing but the ma. What is that ma? M is the mass of that particular body and a is the accelerations of that particular body. So, from calculating these equations we will get the accelerations is g sin theta. But there is one small problem, because as this will be into the opposite directions of that, so it should be the negative value. So, the final equation will be a is equal to minus g sin theta. Next, we will go for the case 2 applications. In the case 2 applications, from this particular figure we can understand that here we are thinking that body is in motions. So, suppose I am a body, unless and until I will get any pressure, so I will be in the rest positions. So, when some pressure will be applied on us, so first that force will acting on me, so I need certain time to get start, then only I will try to move. So, automatically there will be two types of friction will takes place, which is known as the static frictions, and another one will be the kinetic frictions. So, when we are talking about the static frictions, so static friction will be simple, it will be the mu s into n, that nothing but the mu s mg cos theta, because n value we are getting from this first equations. Then our total net frictional force will be more than the frictional force into the static directions. Why it is? Because unless and until there will be that force more than the frictional force of my static case, otherwise I will not come into the moving conditions. So, I need extra force just to react against the environment. So, from these particular equations we will get that F net is nothing but the minus mg sin theta, which one we are getting is from these particular equations is nothing but the mass into accelerations of that particular body is more than equal to mu s into mg cos theta. So, from these equations we can calculate the value of a accelerations. Accelerations of that particular body is a is equal to g into mu k cos theta minus sin theta. Now, if the acceleration will be 0, here we are keeping a is equal to 0, that means we are keeping the velocity into the constant, there is no accelerations of that particular body. In that particular case your mu k will be mg sin theta by mg cos theta. If we cancel that mg, so sin theta by cos theta, it will give you the mu k is equal to tan theta. So, from that particular figure we can calculate the frictional coefficient or into kinetic motions, which is nothing but the tan theta of that particular figure. Next one is called the rolling frictions. As I already explained that when a tire or any movable part is moving onto a surface, it will generate certain kind of frictions. So, that friction is known as the rolling frictions. The force that resists the motion when a body rolls on a surface is called the rolling resistance or the rolling frictions. The example of the rolling friction is a tire is moving onto the road, or maybe any kind of cycle tire, or maybe car tire, or maybe automotive tire, it is continuously rolling onto the road surface and it is doing rubbing with the road surface and it is creating certain kind of frictions against the motion or maybe the velocity of that particular body. So, rolling friction works because of micro welds. It is quite less comparative to the static frictions, because static frictions means is totally depends upon the contact area of two particular bodies, but rolling frictions sometimes one body is into the static motions, another into the dynamic motions. So, that is why the rolling frictions generally little bit lesser than the static frictions. So, the simple equations of that rolling friction is equal to F r is equal to mu r into W. This W is nothing but the weight of that particular object or maybe the body, either it may be tire or maybe it may be bicycle tire or maybe any kind of globe or any kind of materials which is having circular in shapes. Not only that, we can use these techniques for the ball bearing too, because ball bearing also shape is round shapes, it is having the globular shape, so which is having a W. So, it is totally depend upon the weight of that particular material. So, from this particular case you can understand that tire is rotating in these directions, vehicle movement is in these directions. So, automatically the friction will force into the opposite directions of the motions. Next is called the fluid frictions. Fluid frictions is nothing but, as I already explained, that when we are swimming into the water, so our water is giving some resistance to our body by which we can't go further or maybe in a high velocity. So, that friction is known as the fluid frictions. So, fluid frictions means it is the force which resists the motion of object when it moves through liquid or gas. Also, the best example is that when you are taking certain kind of medicines like tablets or maybe capsules, so through water we are taking it and directly it is going into our stomach. So, when it is going to our stomachs, so through water also it is creating certain kind of frictions by which the outer surface of the capsules is getting melted and the only medicine is directly going to our stomach and it can do the remedy to our body. So, from this we can understand that how the fluid frictions is helping to our body. So, all gases and liquids are fluids, this is the normal as we know. The resistance to flow is also termed as the viscosity. So, in this particular case whatever the resistance the material is getting while it is going through the fluid is known as the viscosity. So, the resistance varies from layer to layer in a fluid flow, the velocity variations is termed as the velocity gradient. So, suppose we are having some pipes and if through that pipe the water is going in a particular velocity. So, if we see that the velocity of that particular will be higher at the adjacent layer of the pipe itself, and if the velocity of that particular water at the middle of the pipe will almost become 0, then again it will increase up to the outermost layer. So, the velocity will be like this here, like this way. So, the velocity will be varies in such a manner. So, in this particular case when we are calculating the velocity gradient del V is nothing but the del U by del Y. So, del U will be the velocity difference in between the first layer and second layer, and del Y will be the distance in between the first layer and second layer. So, from this particular case we can calculate that del V is equal to del U by del Y, and whatever the friction is generating over here, the friction generating at the fluid will be F is equal to mu into A. Mu into A is the area at that particular point into del V. So, this mu will be the coefficient due to the fluid. Next we are talking about the friction of a materials. So, as I already told in our first slide and in the subsequent slide also, that friction can occur to any material, whatever the material we are using in our day to day life. So, the friction of material depends on metering material operating conditions and surface preparations. It is also influenced by material properties and environmental effects influencing surface chemistry of material. So, the thing is that from this particular line we can understand that unless and until the two material will not come into the contact, there will not be any friction. So, friction of metal and alloys, clean metal and alloy surface in contact exhibit high adhesions and consequently high frictions, but the slightest contamination reduce adhesions resulting in reducing frictions. That means, if I am having two bodies and if the two bodies is touching each other, means the contact area in between these two bodies is higher, then it is very difficult to detach these two bodies. That means, frictional force is more in this particular case. And if in between this surface, if I put certain kind of fillers which is into the very small size, or maybe I can put certain kind of dust particles over there, or maybe any kind of lubricants, so the automatically the sliding in between these two will be increased, so automatically the friction force will be reduced. Then second one is called the high friction because of large contact areas and small elastic recovery. And the third is that effect of temperature, because effect of temperature also creates a big role for any kind of frictions, because the surface heating results in solid state phase transformations which might improve or degrade the surface properties. So, when we are preparing certain materials and we are adding certain kind of fillers into it, so when we are giving a particular heat to that this material, maybe this particle will be activated. Due to that activations, maybe this outer surface may get lubricated. Due to that, maybe friction can be decreased, or maybe sometimes it can be opposite also, that the resistance in between these two can be increased, so that the friction will be more. Then the example for friction of ceramics, what does it means? Fracture toughness is the most important factor influencing the friction in ceramics. Friction of all ceramics decrease with increase in fracture toughness. Temperature linearly influence the friction of ceramics. So, any kind of ceramic materials, when we are dealing this kind of materials for the high temperature applications, because as we know that ceramics has the ability to withstand high temperature. In this particular case, the fracture toughness is the main factor for any ceramics materials. Then friction of polymers, they exhibit low friction compared to metals, alloy and ceramics, only used unlubricated in tribological applications, because polymer is having certain kind of lubricating type of nature. So, by which it can generate the less resistance in between them, so that its friction is little bit lesser in compared to ceramics and the metal surfaces. And the last one is called the friction of solid lubricants, exhibit lowest frictions, because you are using here certain material which itself acts as a lubrications. So, for these particular reasons, they are creating some kind of lubricating material in between the mating surface, thus lowers the frictional force at that particular juncture. So, solid lubricants like graphite are low energy surfaces showing little adhesions, thus their frictions always low. Environmental gases also decrease the friction because of their chemical reactions with these lubricants. So, generally when we are talking about any kind of nanomaterials, any kind of nanofillers, generally we prefer to use any kind of carbonaceous materials, because carbonaceous materials having less frictions. So, it will generate less frictions, less temperature for that particular material, so that that material can use for longer time. Then the next slide we will see that how we can control the friction in between the mating bodies. So, as already I have told you that by using any kind of lubricant, by using any kind of grease, we can reduce the friction in between the mating bodies. So, controlling frictions in an important parameter for smooth function of machines and improving their life. Various methods can be used for this. Number one is that add lubricant for smooth functioning. You can use certain kind of lubricant, so that it can lubricate or maybe make it slippery in between the mating surface. replace rolling with sliding, since rolling friction is low, as I have already explained that rolling friction is much lower than the static friction. Smooth the surface, as rough surface provide more frictions. So, from the particular first image, if you can remember that I have shown that if our surface is not so smooth, so there will be a chance of that contacting area which can create some kind of interlocking in between them, so that automatically the frictional force will be more. Fourth one will be the put ball bearings in wheel, so that it will create certain kind of rolling frictions instead of making any kind of static frictions. Use of nano fillers to control the frictions, that is why generally we are using certain kind of carbonaceous fillers like carbon nanotubes, graphite, graphene, then fullerene, then carbon dots, so that it can reduce the frictional force in between the materials. Then next slide we will see that for losing the friction, why we are doing the surface engineering, right. So, just to reduce the friction, we are doing the surface engineering by means of any kind of coatings, or maybe by adding any kind of nanofillers to a particular materials, or maybe the material itself is acting as a self lubrication or maybe self lubricating. So, surface engineering process are carried out to control frictions and change the physical and chemical properties of material. This can be done by coating. So, first one is known as the coating. What are the coating? Thin film coating. So, generally we are making certain kind of materials, on top of that we are doing certain kind of coatings, or maybe using certain kind of materials which is reducing the friction itself. How we are doing? Generally we are doing it by the CVD, chemical vapor deposition method, PVD, physical vapor deposition method, by sol gel technique. So, there are several types of process by which we can do the coating on different materials like semiconductor, solar cells, flat panel displays, biomedical, machines. So, any kind of things we can do it. Next is called the sputtering deposition process. In this process, the coating material is ejected from solid surface by bombardment of high energy particles. So, we are having any solid particles over there. Now, we are doing the bombardment of electron on that particular material, so that this material will getting into the vapor conditions, and then that vapor will deposit onto some material, so that it will do the coating of that particular material. Last one is called the thermal spraying. Thermal spraying is nothing but the, we are having some material, we are heating that material is coming into the liquid formations, then like painting we are allowing those material to fall on a particular body. So, give a coating. This is known as the thermal spraying. This is most versatile technique for application of protective coating. Application of thermal spraying by spark jet process are observed while joining metallic components, surfacing or overlaying operations. Now, we will discuss about the nanotechnology and the friction tribology. What are those? So, nanotechnology is nothing, as I already discussed, is the dealing of the materials or maybe the particles which are into the nanoscale. Now, as I already told that when these particles we are using in our day to day life product or maybe in our day to day life, automatically these particles also come into contact with each other, and they are creating certain kind of frictions. To avoid those frictions, whatever the technology we are adopting, that is known as the nanotechnology against frictions, or maybe the friction tribology. Though friction tribology is an old concept, but recent developments in nanotechnology and nanoscience helps us to investigate friction on nanometer scale. There are several techniques by which we can measure, we can detect the frictional tribology onto the nanomaterials. Those are like STM, atomic force microscopy, then FAM, LFM along with specific friction research equipments, surface force apparatus like quartz, crystal microbalance, which help scientists or investigate to measure that there is any kind of frictions onto the nanomaterials or how to control their properties. Use of nanofillers also improve friction properties, like Rain et al. carried out studies of graphene and polystyrene functionalized graphene filled phenolic composites and observed reduction in coefficient of friction because of self lubricating properties of graphene. As I already explained that the carbonaceous materials is having that capability that it can act as a self lubricating material. So, that is why nowadays the researcher, the scientists are trying to use this kind of nanofillers for making any kind of products, so that there will be a frictionless product and its life and other properties like mechanical properties, chemical properties will also be increased. And last one is called the 0 dimensional nanomaterials are applied in lubricants to reduce frictions, any kind of carbon blacks or maybe carbon dots we are using to reduce the frictional properties. So, in summary we can say that friction comes into play whenever two surfaces are in contact. Friction is gaining importance in many engineering like transportations, automobile brakes, rail adhesions, road slipperiness, measurement and household uses like matchsticks. Friction arises due to adhesions and deformations. Unless and until two body will come into the contact, they will stick together, there will not be any friction. So, automatically there will be a resistance in between the two bodies, then only the frictional force will be generated. It is typically characterized by a coefficient of friction which is the ratio of the frictional resistance force to the normal force which presses the surface together. Various types of frictional force exist like rolling friction, fluid friction, static friction, kinetic friction, etc. Already I have explained in our earlier slide. Surface engineering process are carried out to control frictions and change physical and chemical properties. In our subsequent slide or maybe in depth in our next topic, we will discuss that how surface engineering is affecting the frictions, how it is helping to reduce the frictions so that the material properties can be increased. And the last one is the nanomaterials are used as fillers in different materials and they improve the frictional properties because of their self lubricating properties. Not only that, nanofillers is only increasing its frictional properties, also it is increasing its mechanical properties, electrical properties, thermochemical properties, any properties. So, nowadays nanofillers is playing a very vital role for doing any kind of surface engineering to reduce its frictional resistance and also to increase the mechanical and other properties too. Thank you.